This is part 2 of the chemical calculations mind map. So previously we looked at the balanced chemical equation, how to read this balanced chemical equation. So in terms of mole, remember the number in front of the chemical formula is actually the number of mole, or the coefficient of the chemical formula is actually the number of mole. So in terms of mole, we can say that 2 mole of nitric oxide reacts with 1 mole of oxygen and to produce 2 mole of nitrogen dioxide. Now in terms of mass, so what is the mass of 2 mole of nitrogen oxide or nitric oxide? Okay, this is actually nitric oxide, again from the triangle mass mole mR. So in terms of mass, there will be mole times the mR, which is 2 times the mR for NO, which is 14 plus 16, which is 60 gram. So you have 60 gram of NO, and likewise for oxygen, you have got 1 times 16 times 2, which is 32 grams of oxygen, and to produce 2 times 14 plus 16 times 2, and that would give you 92 grams of nitrogen dioxide. Now how about in terms of volume? Now previously we also looked at this formula, which is volume of gas at room temperature and pressure equals to the mole times 24 dm cube. Okay, any volume any gas at room temperature and pressure, the 1 mole of it occupies 24 dm cube of volume. So in terms of volume, we can calculate the volume of 2 mole of nitrogen oxide, which is the mole times the 24. So 2 times 24 is 48 dm cube, reacts with 1 mole, which is 1 times 24, equals to 24 dm cube, and to produce 2 mole, which is 2 times 24, 48 dm cube. So if this 48, 24, 48 all divided by 24, that would give you 2 mole, 1 mole, 2 mole. And isn't it the same as 2 mole, 1 mole, 2 mole? Yeah, so this actually shows that for reactions that involve gaseous reactants and products, the mole ratio, which is 2:1:2, is actually equals to the volume ratio, which is 48, 24, 48, or 2:1:2. So the mole ratio equals the volume ratio. Only for gases. Let's look at the example here. Okay, ammonia is manufactured by reacting nitrogen and hydrogen. So which means that ammonia is the product, nitrogen and hydrogen are the reactants. Calculate the volume of nitrogen that reacts with 60 cm cube of hydrogen. So again, we start with the first step, which is writing a balanced chemical equation. So nitrogen is N2, is not N. Hydrogen is H2, it is not H. And ammonia gas, you have to memorize the chemical formula, is NH3. Again, we need to balance the chemical equation. There are 2 N atoms, 2 nitrogen atoms on the left hand side of the arrow. On the right hand side, there is only 1. So we put a 2 here. But when we put a 2 here, how many hydrogen are there? 6 hydrogen atoms on the right hand side. So on the left hand side, we have to put a 3 here. So at this point, the chemical equation is balanced. Second step, write down the information given below or above the chemical formula. So you're supposed to calculate volume of hydrogen. So you're supposed to calculate the volume of hydrogen that reacts with 60 cm cube of hydrogen gas. 60 cm cube. Okay. So for the second step, you have to look at the second step we have already done it, which is writing the information below or above the chemical formula. Third step is the mole ratio. So mole ratio of these two, which is nitrogen to 3 mole of hydrogen, 1:3. And remember, mole ratio equals to volume ratio. So how much volume of hydrogen we have? We have 60 cm cube. So 3:1. 60 is to 3:1 is divided by 3, right? So 60 must be divided by 3, which is 20 cm cube. Mole ratio equals to volume ratio. So the question wants volume, right? So volume of nitrogen, which is 20 cm cube. Let's look at example 2. Butane burns in oxygen to provide carbon dioxide and water vapor. So butane burns in oxygen. These are the reactants, and the products will be carbon dioxide and water vapor. Okay, write down the chemical equation. C4H10 plus oxygen produces CO2 plus water. And you have to balance the chemical equation. Now this equation is not easy to balance. Okay, there are 3 oxygen. So always try to balance the elements that appear in the fewest number of places. Okay, so for example, hydrogen appear in 1, 2 places. Okay, oxygen appear in 1, 2, 3 places. So don't balance oxygen first, balance hydrogen first or carbon first, because both hydrogen and carbon appear in 2 places. Okay, let's balance carbon first. 4 carbon on the left hand side. So on the right hand side, put a 4. When you put a 4, carbon is balanced. What about hydrogen? Okay, hydrogen, you have 10 hydrogen. This one 2. So you put a 5 here. So hydrogen and carbon are balanced. How about oxygen? Okay, oxygen, there are 5. There are 8. 8 plus 5, 13. There are only 2. So 13 over 2. That will give you 13 over 2 times 2. That will give you 13. So at this point, the the chemical equation is balanced, but you cannot have a fraction. So everything must be multiplied by 2. That will give you 2C4H10, 13O2, 8CO2, 10H2O. Yeah, this is the balanced chemical equation. That's the first step. Second step, write down the information given, as well as the things that you need to find above or below the chemical formula. So calculate the volume of carbon dioxide. You need to find out what is the volume here. When 3 dm cube of butane, this is butane, 3 dm cube burns completely. So that's the second step. Third step, mole ratio. What is the mole ratio? The mole ratio will be in between butane, which is 2 mole, as well as carbon dioxide, which is 8 mole. Okay, mole ratio equals to volume ratio, right? So you can actually write the volume here, 3 dm cube. This is how much? So 2:8. 3 is to how many? Now 2:8, isn't it the same as 1:4? So 1:4, 3 is to 3 times 4, because 1:4 or 2:8 is 2 times 4 equals to 8, right? So 3 times 4 equals to 12 dm cube. So fourth step, volume of carbon dioxide is 12 dm cube. Okay, 2:8 is times 4. So 3 is to 3 times 4, which is 12. So 12 dm cube.